My name is Axel Scherer. I will give you a quick introduction into scoreboards for UVM. So scoreboards deal with checking of the device operation. In order to check something, you need information. And this information is basically coming from interface UVCs in forms of transactions. So once you have these transactions, you can perform the checks and determine if the device operates as you expected. The actual checking, you most likely, if it's a complex model, you have potentially a reference model in C or system C or something like that. If it's a simpler model, you might just implement it with some abstract system Verilog constructs. The scoreboard is located inside of the module UVC, which is responsible for the whole device operation. And inside of the module UVC is actually another layer called a monitor where the scoreboard resides. So in our whole test bench scenario, in order to check the device operation, we include a scoreboard in our module UVC, right, to perform basically all the traffic that we see here going through the device if that is resulting in the expected behavior. Let's look at some code for this. We are starting out with the module UVC, and inside of the monitor is where the scoreboards are located. In this particular example, we have a UART controller that has a UART and an APB port, right? And there's two data channels. We can transmit data from UART to APB, and we can receive it from APB back into the UART. Subsequently, we check these two channels independently in two different scoreboards, one from the transmit side and one for the receive side. Let's look at the transmit side. So basically for the operation of data going from the UART into the APB. So you can see this scoreboard is implemented as type UVM scoreboard, and we can set up all kinds of auxiliary variables and constructs to perform our checking. In this case, we don't have an actual reference model. It's a very simple design, and we are just checking the data flow. However, we have here an array data to APB, so we are keeping track of what we want to send to the APB side inside of the scoreboard. Okay, so that's our reference basically. In order to get the proper reference, every time the UART sends traffic or transmits data into the device, we need to know what's going on. And that's what's done in this particular function, right? So from the ports we're taking that frame, right, which is the data from the UART, and we're storing it inside of this array. So we're using the pushback to implement a FIFO, and we are loading up all the data that's coming out, right? So you can have a whole series of data, and it will chronologically push into the FIFO. Okay, so now we have our reference data. Let's check the output at the other side, right? What is the APB side seeing? And we are basically capturing the transactions at the APB side. So if we read at the APB side, we will know here, and then we perform the actual checking. Okay? And that's happening here. The first thing we need to do is to get a reference value. So we are popping off the top of the FIFO the last value of the data, the oldest value of the data. And we are storing that in our little temporary variable. And then we perform the actual checking in this comparison, right? So if the data is the same that was in the FIFO that came from the APB transfer, we are good. And we're issuing a pass message right here. If not, we are issuing a fail message, right? So this is a very simple data flow that was implemented straight in System Verilog for the simple transmit from UART into APB. You can imagine for more complex models, you probably have a reference model inside here where you can pull the expected values out of. You can find more videos like this either on this YouTube channel or at support.cadence.com at the video library for the Incisive Simulator. Have a great day, talk to you soon, and thanks a lot for listening. Bye.